Hey Algebra 2, we're going to transform some more parent functions. This time we are going to incorporate a, and in this video we are going to stick to absolute value and quadratic. The next one will have cubic and square roots. So we haven't addressed what a does yet. We have three different boxes. So if a is any kind of a negative number, it will make your graph reflect. Reflect means that it's going to open down. So if it's a quadratic, it would look like this. If it's an absolute value, it would look like this. And we'll show you what the others do on the next video. And remember that a normal quadratic would open up and look like this, and a normal absolute value would open up. If a is any number between 0 and 1, we're talking a fraction such as a half, a fourth, 2/3, etc., etc., it will do what we call compress. So compress means it's going to kind of be smashed down and maybe look like this. So here's what the normal one does, and then here's what the compressed one does. So it's as if we took it and we pushed it down. It's more like flat, fat, something like that. That's just supposed to be a small a. I don't know what my computer was doing. If a is a number greater than 1, such as 2, 3, 4, 5, 28, it will stretch. When it stretches, it kind of looks like this, or if it's an absolute value, it would look like this. So when you take it, you're stretching all the y values up, and so it's going to result in what looks like, that's supposed to say skinny, a tall and skinny graph. And then once again, to recall, if h will move something left or right. If I wanted to go left 7, it would be like y equals the absolute value of x plus 7. And if it was going to go to the right 2, it would be the absolute value of x minus 2. And k goes up and down. So if we wanted to go up 3, you would have y equals absolute value of x squared plus 3. Or if we wanted to go down 8, we would have y equals maybe the absolute value of x squared minus 8. So the a, what we're going to explore today mostly is the number out in front of your grouping symbol. So let's draw the basic parent and see if we can recall what it does. So the basic parent function, and I'm going to deal with absolute value of x. Yep. So if x was -2, the absolute value of -2 is 2. The absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2. So we have these points here. And let's see if I can connect the dots all the way back. Okay. So this is, the black one is going to be my parent function. It says draw in 3 times the absolute value of x. All right, so if we look up here, if you have a number out in front and that number is bigger than 1, I'm expecting this graph to stretch. I'm going to plug in my same x values, -2, -1, 0, 1, and 2. All right, so when I plug these in, this says 3 times the absolute value of -2. The absolute value of -2 is 2. And so when you have a number right in front of a grouping symbol, that's multiplication. And so this is still multiplication, but when I took the absolute value, that just became +2. And so 3 times 2 equals 6. All right, so you can already start to see. On the parent function, my y value was 2. Ooh, now it's 6 because I multiplied it by 3. Let's plug -1 in for x. So 3 times the absolute value of -1. The absolute value of -1 is 1. That was multiplication. This stays multiplication. 3 times 1 is 3. 3 times the absolute value of 0, and 3 times 0 is still 0. 3 times the absolute value of 1. The absolute value of 1 is 1, and 3 times 1 is 3. And you can see if you plug 2 in for x, you would have 3 times 2, which equals 6. So all of these y values are 3 times the amount that they were in the parent function. So let's plot these points. -2, 6. -1, 3, my origin, 1, 3, and 2, 6. All right, so then when I sketch this graph, I see that this one is kind of taller and skinnier than my parent function is. So when you stretch, that's why I say it kind of gets tall and skinny, because you take all of these y values and you're multiplying or stretching them up instead. Here's where the 1, 1 point was, but I had to multiply it by 3. At 2, 2, I had to multiply it by 3, so that stretched that point up to 6. All right, let's see what happens when it's 1/2. If you look back up at the top, it says that if your number is between 0 and 1, which a half is, this should compress. I'm expecting a short, fat one. So if you were short and fat, you would take the parent and like smash all those down by a half. I'm going to stick with my same x values. And I'm going to put it on the screen so you can see. Okay. All right. So if you have a number out in front of an absolute value symbol, this is multiplying. That says you take 1/2 times the absolute value of x. Okay, so x is -2 now. So I have 1/2 times the absolute value of -2. Order of operation says you got to take absolute value first. The absolute value of -2 is 2, and a half of 2 is 1. I have 1/2 times the absolute value of -1. The absolute value of -1 is 1, and a half of 1 is a half. I have 1/2 times the absolute value of 0. The absolute value of 0 is 0, and anything times 0 equals 0. 1/2 times the absolute value of 1. The absolute value of 1 is 1, and a half times 1 is a half. Plug 2 in. That's a half, Amy. There we go. All right. A half times the absolute value of 2. The absolute value of 2 is 2. And a half of 2 is 1. So now I have these points that I can plot. So I have -2, 1, -1, a half. So we're just going to estimate somewhere between 0 and 1. I have my origin, 1 1/2, and 2 1. So this is what 1/2 times the absolute value of x looks like. So now you can see that when I say that it is compressed, it means that it's smashed down and it is more flat than your normal parent. All right, let's go with a quadratic. All right, so I have a is negative, or if you don't like that, you can put a 1 with it. So a is -1, h is your 4, and k is your 2. So if a is -1, if you look on the other side, that says that it's going to reflect. So it's helpful to know what these numbers do so that you know that you get a correct graph out of it. So this is what a normal absolute value, a quadratic looks like. If a is negative, I know that my graph should at least be opening down now. So if you don't get a graph that opens down, you need to double check your math. Your h is that 4 right there, and your x always lies, so that part means it's going to go left 4. And the fact that k equals 2 means that it went up 2. You got to remember that your vertex is always h comma k. So my vertex is the opposite of 4, so it's -4 comma 2. So there's where my vertex is. It's still the same from the last section. I'm going to choose 2 values that are smaller and 2 x values that are larger. So on your number line, if you had -4, if you were going to the smaller, that means that you would be going left on the number line. So that would be -5 and -6. And then if you were going larger from -4, that means you would be going to the right on the number line. That means your x values are -3 and -2. Okay, let's plug them in. All right, so I have negative. I'm just going to use these larger ones, and then I'm going to reflect the values over. So I have -3 plus 4 squared plus 2. This negative out in front stays down. Order of operation says you got to do the math inside those absolute value symbols. You got to square it before you change the sign. So 1 squared is still 1. So that's how I end up with -1 plus 2, which equals 1. So when x is -3, y is 1. Now I'm going to plug -2 in. So I have -2 plus 4 squared plus 2. Got to do the math inside your grouping symbols first. You have to square the number before you change its sign. So 2 squared is 4. So therefore I have -4 plus 2, which equals -2. Quadratics have symmetry. So if this y value is 1, you can reflect it, and that one is also 1. If this x is negative 2, you can reflect it, and that one is also negative 2. So let's plot these points. I always start with the vertex, so negative 4, 2. The other thing that I tend to do is I sketch in, this is technically called the axis of symmetry. We'll get more into that in a future section, but there's your axis of symmetry. That is the imaginary line that divides your graph in half. So I have a point at negative 6, negative 2. So if this is 2 points to the left, I would have its mirror point 2 to the right, which corresponds to negative 2, 2. And then you have negative 5, 1. And then I would reflect it over that yellow line, which is called the axis of symmetry. And then finish sketching it, and that's what it would look like. Your domain is negative infinity to infinity. That says what x values can I plug in? Anything you want. Your range are your y values. What y values do you get out of it? So we always start with small and go up to the biggest answer. So these arrows down are saying they go down to negative infinity. So since it's opening down, we go from negative infinity up to 2. So you follow that across, negative infinity to 2. Your x-intercept, where does the graph cross the x-axis? In this particular class, at this point in time, we are just going to estimate. So it looks like it's crossing between negative 2 and negative 3. So I would say about negative 2.50. And then it's also crossing over here between negative 5 and negative 6. And I would say that's about negative 5.50. The y-intercept you can get. To figure out the y-intercept, you set x equal to 0 and you solve. So it looks like we have to do math one more time. Negative 0 plus 4 squared plus 2. 0 plus 4 is 4. 4 squared is 16, so I have negative 16 plus 2, which equals negative 14. So your y-intercept, you can always, always, always be exact about. That is 0, negative 14, because you can plug it in and always find it. Stay tuned for the next video for the other two functions.